Hopefully you're starting to see how the input and output pairs are related when we have a simple quadratic function and what happens when we change the coefficient in front of the x squared term. Remember, when solving for y, you always do the exponent before multiplying. So x squared before you times by 2. Also remember that on all of these tables, we get a mirror of outputs on either side of the 0, and that we can get any of these tables from the original by multiplying by the coefficient of the x squared term. Let's look at a tricky one. Leaving y equals x squared in its table for reference, let's look at y equals negative x squared. The reason this can be a tricky problem is because a negative times itself is a positive. A common mistake is to plug a number in for x. Let's say we plug in 5, we get y equals negative 5 squared, and end up with a positive result because a negative times a negative is a positive. But this doesn't actually work. Y equals negative x squared actually means y equals negative 1 times x squared. The coefficient is negative 1. It's easier to see the mistake now. We need to do exponents before we multiply. So if we plug in a 5, we get negative 1 times 5 squared. 5 squared is 25, and negative 1 times 25 is negative 25. So it was a mistake here to think that this negative would be squared and give you a positive number. Actually, the negative 1 is multiplied at the end, and it ends up giving you a negative. So what will the table look like for y equals negative x squared? Well, when we plugged in 5, we ended up with negative 25. This suggests that we might end up with the same table with negative. This makes sense because y equals x squared is the same as y equals negative 1 times x squared, except at the end you multiply by negative 1, changing everything from positive to negative. Let's make sure this works out by plugging in a few more values. If we plug in a 2, 2 squared is 4, and negative 1 times 4 is negative 4. So our pattern seems to be holding up. Let's plug in a negative number. If we plug in negative 3, we get y equals negative 1 times negative 3 squared. Negative 3 squared is positive 9, and negative 1 times 9 is negative 9. We could try all the numbers, but our pattern does, in fact, hold up. So y equals negative x squared has all of the same outputs, except instead of positive, they are negative. Here are all the tables we've made so far. This is the original pattern. I didn't go out to 5. I just went to 3 on either side to shorten it. All the outputs are doubled and tripled and multiplied by 10 and made negative.